So hello guys, welcome back to this video, and in this video we are going to solve next problem of our series, which is FRAZ DSA sheet, and we are solving linear DP section. So today we are going to solve the second last problem of this section, partition array for maximum sum. Let's open it. So the problem states that given an integer array ARR, partition the array into contiguous subarrays of length at most k. Please note that it is asking for subarray. After an at most k, okay, you can take subarray of length at most k. After partitioning, each subarray has their values changed to become the maximum value of that subarray. Means, so if you pick some subarray of length k, so whatever the value of the maximum among all the elements in that subarray, that will be the then the total value will be the number of element into the maximum value for that particular subarray. That is the cost. Means cost means that is the some profit, some sum, you can say sum. So here it is asking return the largest sum of given array after partitioning. So we have to find out the largest sum. So out of all partitionings that are possible in that subarray, we have to return the maximum. So let's try to see this example on whiteboard. So first, let me write this example first. 115, 7, 9, 2, 5, 10, and k is 3. Okay. So let me share my whiteboard and then we will understand how this is working. So just see. So this is our subarray, as this is our given array. So what we can do is we can at most partition this subarray into multiple segments of length k. At most k. It means you can also create a subarray of length 1, length 2, length 3. You cannot create any subarray of length 4. So if you notice this example, so in this in this array if you create this subarray, let's say this is one partitioning. I'm just showing you example. So this is one partitioning. So in this partitioning, in this subarray, this is 1, this is 2, this is 3. This subarray, the maximum is 15. So the cost will be 15 into 2. This array, the maximum is 9, so the cost is 9 into 3. In this array, 10 into 2. So what is the total cost? Means total sum 30, 27, 20. So it would be 30 plus 20, 50, 77. Total is 77. So is there any other arrangement possible where the answer is maximum? Let's try to see one more. So 1, 15, 7, 9, 2, 5, 10. Okay. So let's say, so if let me select this first three, then this two and this two. So here the maximum is 15. So 15 into 3, 9 into 2, 10 into 2. So here it is 20, 18, 45. So it would be 65, 75, 83. Okay. So it would be 80, I guess I'm correct, 83, 45, 20, 65, 25, 84. It's 84. Now let's try to take one more possibility. 1, 15, 7, 9, 2, 5, 10. Let's say this time I am taking this 3 and this 4. So here it's a cost sum is 10 into 4, 15 into 3. It's a 40 and so yeah, it's a 45. But the problem is you cannot take this one because here the length is 4. you cannot take any subarray of length 4. So how we will solve this? So here you can see that there are multiple possible scenarios. So we can take any subarray. So in this case, we will use our dynamic programming approach to solve this problem. So what we did, so first let me write my fundamental DP formula, that is special DP formula. So first step is define your DP state. So here I am defining DP of I. How I am defining DP of I? So DP of I is if we have only first I elements, then what will be the maximum sum that we can construct, right? Now, second step is we will solve for solve for smaller problems. So let's try to solve for small problems. So let me first write this 1, 15, 7, 9, 2, 5, 10, 2, 5, 10. So this is our array. Now we will start with our DP of 0. So DP of 0 means, so here in code I will use 0 index. Here I'm using 1 based indexing for understanding, better understanding. So okay, DP of 1 means we have only one element. Then what will be the maximum sum? So DP of 1 will be 1 because we have just one element. So if there is only one element, that is the maximum. So and that is also the length of that subarray is less than k. Here k is 3. So our answer is 1. Now let's move to DP of 2. So DP of 2, we have array 1 and 15. Okay. So DP of 2 will be what? DP of 2. So DP of 2 will be 30. How? Because you can take this, you can take this. So DP of 2 will be 30 because you can pair up this. The length is 2, so you can make it 30. Now DP of 3. So DP of 3, you have 1, 15, 7. So if you pair up 7, 15, 1, so you can pair up 3. So for DP of 3, it will be 45. Okay, because you can make all this element 15. Okay, so now the interesting thing is now you can use the sub problems to solve the higher problems. So now DP of 4, DP of 4, now we have 1, 5, 15, 7, 9. Okay, so if you try to start from here, so you have a lot of possibility. You can pick these two, then you can use the answer till here, or you can use, so how many possibility, just see here. So 1, 15, 7, 9. So either you can just pick this one because here the size is 1. You can take at maximum size, the subarray of maximum size k, that is 3 here. So here you can, if you just uh, take this 9, so what will be the answer? This 9 plus whatever the best answer till here. So that is 9 plus dp of 3. One possibility. Now there is also one more possibility that you can pair up these two. If you can pair up these two, then answer will be 18 because here 9 is maximum, so 9 plus 9. So you can also replace 7 with 9. So 9 plus 9 is 18 plus dp of whatever the best answer till here. Now one more option is there. One, you can also pick these three, and in this case the maximum is 15. So the total value will be 45. So 45 plus dp of 1. So here so many possibility. Out of this three possibility, you cannot take four because the k is 3. So out of this four, this all possibility, whatever the maximum you will store in the dp of 4. Okay. So similarly dp of 5. Again 1, 15, 7, 9 and 2. So you can take this alone, then 2 plus dp of 4. You can take this 2, so 18 plus dp of 3, or you can take this 3. So it's a 18, it's a 9, 20, it's a 27 plus dp of 2. So you have this possibility, this possibility, this possibility. Out of all these three, you will take the maximum one. So similarly, you will try to calculate the answer for all the uh, dp of i's. Then your final answer will be dp of n, because we have all n elements and we have calculated the what is the maximum sum. Now let's come up to the time complexity. So time complexity will be order of and into. So for every I, let's say we are at this I. So for every I we are traversing till we are trying to take each and adding one and more element, and this another nested loop will run till size k, because we can only consider k elements in one subarray. So we will just try to uh, iterate uh, previously till length k. So it will be n into k. And for calculating maximum, we will just create one max variable which will just update the maximum, and at the end of the loop, we'll just update. Okay, so this is the time complexity. Space complexity, if you talk, so space complexity will be order of n. So this is the overall solution for this problem. Let's try to uh, see the let's try to see the code. Now I will create one vector of int. Let me first int n is equals to array dot size. Now int dp n. Okay, mem set dp0 size of dp. ओके, जीरो से सेट कर दिया, हमको मैक्सिमम चाहिए. सो व्हाट विल डू, आई विल स्टार्ट विद 0. 1 से भी स्टार्ट कर सकते हैं, और एज यूजुअल डीपी ऑफ 0 को नम्स एरे ऑफ 0 लिख सकते हैं, क्योंकि एक एलिमेंट है तो ये आंसर होगा. फिर i लेस देन एन i प्लस प्लस. नाउ what we will one we will create max variable maxi for just keeping track of maximum element. So currently the maximum will be nums of I. Now I will run a j loop greater than equals to 0 and we only run this j loop till k, length k. So count will be 0 and we'll just write count less than k. Now what I will do, so this maxi will be max of maxi and nums of j. So we have to also initialize j. So j will be start from I and it will go till 0. And if the count will be equals to k in one subarray, the count will be k, we will break this loop. So now what we will do, so we have maxi, and so we will increment our count. So we have taken one element into consideration. Now we will update dp of I with max of dp of I, or count into, so let's say count is 2, means we have included two elements. Out of these two elements, whatever the maximum, we will logically just calculating if we just put the maximum element in all sub replace all the elements in that particular survey with the maximum element. What will be the value? So that will be the count into maxi plus dp of j minus 1. So let's say we are at j. So if we are at j, so we have added the element from index j to I. So whatever the elements in from j to I, that is a part of one subarray. So for that we have the answer as count into maxi and dp of j minus 1. So from 0 to j minus 1 we have already the answer calculated. Previous answer we have already calculated, so we just add the only problem is to just prevent it from runtime overflow. J minus 1 if greater than equals to 0, then we add dp of j minus 1, otherwise we'll just consider 0. Okay, now we will just decrement j minus minus. So this is the final and return. At last we will just return dp of n minus 1. Let's try to run it. So what is wrong? Dp of n, something missed. Nums of I, where we use nums of I? It's array, array, array. Hmm. It should give correct answer. Yeah, it is giving us correct answer. Let's try to submit it. Okay, yeah, it's got accepted. So this is the solution for this video. See you in the next video with the next problem. Till then, keep learning, keep coding, and please like my video, subscribe to my channel, and if you have any query related to this video or any other video, just ping it in the comment box. I will try to answer it. Till then, bye bye.